Welcome back to the unit on transformations. Today's lesson is about slope of a line. You will learn how to calculate the slope of a line on a grid and how to draw a line when you're given the slope. So first let's look at what slope is and how it's calculated. And let's look at the picture here on top. So slope is the incline here as you go up a hill. Here's a hill in the foreground. And slope is measured by calculating how much the hill is rising up and how long it takes it to rise up. So we can see that this is just a very little hill. It rises a small bit and then it rises over a much longer distance. If you look at the lower picture, at the slope here, we see that this slope rises much more than the one in the top picture, and it rises over a shorter distance. So this slope is much steeper. So let's look at slope on a grid, which is like graph paper with horizontal and vertical lines. That's what they mean by a grid. And here we've got a series of triangles all on the same line, ABC, CDE, and FGH. And let's start with ABC, the vertical side, meaning the side that goes up and down, is 3 units long. The horizontal side going across is 4 units long. And looking at vertical over horizontal, 3 over 4, that's the slope. Let's look for CDE. The vertical side is 6 units long. The horizontal side is 8. So the slope is vertical over horizontal, 6 over 8. And let's look at FGH. The vertical side is 1.5 units and the horizontal is 2, so 1.5 over 2. And something to note about all of these 3 ratios here of vertical to horizontal is that these are all equivalent ratios. 3 over 4, if we were to multiply both of these by 2, we'd get 6 over 8, which we have in the second triangle. Or if we start again with 3 over 4 and divide each by 2, we'd get 1.5 over 2, which we have in FGH. So the slope is the same all along this sloping line. This slope is 3 over 4. To calculate slope, you need at least 2 points. So I'm going to mark 2 points here. And you count the vertical distance between them. 1, 2, 3. So that's your vertical distance is 3. Your horizontal distance is 2. So you write it as 3 over 2. And leave it like that as an improper fraction. Don't make it a mixed number or a decimal number. Let's look at the other graph here. Let's pick 2 points and count the vertical change. It goes up 2 and horizontal 1, 2, 3, 4, 5, 6. And we can simplify this by dividing both 2 and 6 by 2, and an equivalent ratio is 1/3. And if we look at the graph, we'll see that if we went up just 1 and over 3, there actually is another point here. And same here, if we went up 1 and over 3. So the slope there is 1/3 or 2/6, they're equivalent. So to calculate slope when you're not given points with a triangle is you find where a horizontal line and a vertical line intersect, and that's a point that you can use, and so on up along the line. So I'm just going to take one of these points. I'm going to go here and count up 2 and across 1. So my slope there is 2 over 1, or just 2. And looking at the second graph, I've got a point here, here, and here. So let's count the vertical distance is 1, and then horizontal is 4. So the slope there is 1 over 4. And to draw a line with a slope of 5 over 4, pick a point. I'll pick here. And a slope of 5 over 4 means I go rise 5 and go to the right 4. And that's my second point. And you can draw it like this, where it continues in both directions. So it's 5 over 4. It goes up 5 and to the right 4. So to summarize, you find your points, count your vertical distance and your horizontal distance between the points, and write the slope in the form vertical over horizontal. And that's also called rise over run. You may see that in some textbooks. So today you learned how to calculate slope and how to draw a line with a given slope. And that's the end of today's lesson.